5 graphs. Okay? So loading 2, 4, 6, and unloading 4, 2. Each time we either loaded or unloaded the beam, we require to plot a graph. Okay? And then on each graph, you're supposed to have 2 lines. In your lab manuals, you will see that you're supposed to have 3 lines because one of them corresponds to theoretical, one of them corresponds to electrical, and the third one, they say, is the mechanical. And once again, since we did not go over this, you don't have to include it. Okay? So 2 lines on each graph instead of 3 lines. So on your graphs, on the x-axis, you're supposed to have stress or strain. Doesn't matter because it will give you the same pattern. And then on your y-axis, you're supposed to have 1, which is distance between the neutral axis and your gauge. Okay? Do you guys get it? So on your y-axis, you'll have 0. This is where your neutral axis is located. And then the very top point will be 4.08, which corresponds to this gauge. And the bottom point would be minus 3.60, which corresponds to this point. Do you guys get it? It's this value minus 4. This way you will be getting the distance between the neutral axis and the gauge. Okay? And on your x-axis, you will have your stress values. So what you're required to do is what we call the linear stress distribution along the cross-section of the beam. Okay? Which means that at each gauge, you're going to calculate how much your stress is supposed to be and plot it on a graph. Okay? And since this is a linear distribution, you don't have to calculate all 10 values. You can just calculate this, and then plot a straight line. Do you guys get why? They're telling you it's a linear distribution. So instead of calculating these 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can just calculate this point, and then plot a straight line. Okay? So these 2 values, I've already calculated them in the previous step to fill out the table. So you can just input them and plot your stress distribution, and this is theoretical. It comes from the formula. Okay? Again, at the top, 4.08, you will have a negative stress. For instance, minus 230 it turned out to. Okay? At the bottom, you'll have something like 220 because the distances are not even. And then this would be a straight line. Do you guys get it? Okay. And then along the way, you will have all your gauges. And at your neutral axis, which is the 0 point, you're supposed to have a 0 stress. And this line should pass by the origin. Okay? So this theoretical line, this is how you draw it. You choose 2 points, the bottom and the top, so that you can reach your limits, and then you draw it. And the second line, which is supposed to be included on this graph, is the electrical readings. Okay? So again, the readings that we took in the lab. And for the electrical readings, you're actually supposed to plot all the values, because even though the theory is telling you that it's a linear distribution, the machine might have not been so accurate, and the distribution might not have been perfectly linear. Okay? So, you guys have the values. Let's say this is 2,000 pounds. For this gauge, if I remember, you had minus 216, okay? And they had some value here, 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 here. And then you can plot your electrical reading line. Okay? So 5 graphs. On each graph you have 2 lines. First line is the theoretical, you're just plotting the equation actually. Okay? You're plotting the equation on a graph where on your x-axis you have your stress, and on the y-axis you have your y. And then the second one is you just inputting the values we got in the lab on this graph. Okay? And why do we do this? We do this for 2 reasons. First reason is to check how much error you have between the theory and the experiment, okay? So whatever the gap is between your lines is the error from this experiment, okay? And the second reason, and you can find this in your lab manuals, is to check where your neutral axis is located experimentally, not theoretically. Because theoretically, we know that the theory theoretically, we know that it's at 4 inches, okay? At y is equal to 0, this is theoretical. Experimentally, your neutral axis is where you have 0 stress, okay? So, in your lab manuals, you will see that you're required to calculate the location of the neutral axis from this graph. Now, do you know how to obtain it, like visually? What's the neutral axis by definition?
0 stress.
0 stress, okay? So, wherever you have 0 stress on your graph, experimentally, is where your neutral axis will be. It should be very close to 0 because this should be a pretty accurate experiment. So, like for example here, it's a little bit below 0, and then you can find where it's located from the bottom. Like in this case, it would probably be somewhere around 3.8 inches. You guys understand what I'm saying? Okay, so let's go over the steps once again. You have to fill out your tables, calculate your stresses at the top and at the bottom each time we load or unload the beam. Okay? And then once you get this table filled out, you have to plot 5 graphs, 2, 4, 6, 4, 2. Remember, we loaded and unloaded. Okay? So 2, 4, 6, 4, 2. And then on each graph, you have to plot a theoretical line, which will be a perfect straight line, which is you just plotting the equation, and then another line, which is your readings from the experiment. Okay? So you can either choose to plot this manually or by Excel. It's totally up to you. It's not so hard. There are not a lot of values. It's really up to you. If you know how to use Excel, then go ahead. If no, you can plot them manually. Okay? And then once you plot these two, you can find the error between the experimental and the theoretical, which is the gap between the two lines. And you can calculate the location of the neutral axis experimentally, which is wherever your electrical reading line intersects the y-axis. Okay? Do you guys understand that? Alright. So I understand it's a little bit heavy. It requires a lot of tables and graphs. Once you do that, you guys will be required to write your own discussions and conclusions like the other labs. Okay? Any questions about this?
How exactly do you want us to calculate the error? Do you just want us to measure it? Or?
No. Well, you can just see it on the graph, okay? And in your sample calculation, you have to include one example of how you calculated the error. Okay? Like percent error is this theoretical minus this experimental divided by this theoretical. You just choose 1 point. Okay? And for this experiment, you will not be required to provide all the percent errors, because whenever I look at the graph, I can see what the percent error is, which is just the difference between these 2 points. Okay? So, you guys understand this? Okay, you will be required to submit this next week. Alright? And next week we will start with lab 4, which is, again, stresses, strains, but this time in aluminum beams, not steel beams. Okay? And then the last lab would be column buckling. Just let me know, what are you studying in class right now?
Composite.
Composite beams. Okay. We don't have a lab on that, but have you already started with Morse circle? You know, Morse circle distribution of, no, not yet? Okay, so we'll discuss this next time. It's not that big a deal actually, especially since for the 4th lab, you only have to submit the analysis. Okay? So, if you guys don't have any more questions about this, you can leave. If you want to check your lab reports, I'll be at the office, okay?